Good morning everyone, welcome back to another episode of Teaching Math. In paragraph 2.3, the focus lies on finding points that are equidistant from two lines. I will also teach you what the incircle is and how to draw it. With that out of the way, let's start the video. By now, we can use the locus in combination with the distance to a point, the distance to a line, and, with the perpendicular bisector, finding points that are equidistant from 2 points. Our last locus line is finding all points inside an angle that are equidistant to both arms of the angle. Sounds hard, but you already know this one. Here, let me show you. This here is angle A. Angle A is 60 degrees, but that's besides the point. If I need to find all points that are equidistant from both arms, I have to draw the angle bisector. Because the angle bisector is a ray that divides the angle in two equal parts, any point on top of that ray will be on equal distance from both arms. So, from this point P, it's the same distance to arm K to arm L. The notation for the angle bisector is dpk is equal to dpl. And we can also use it in an example like this. Plot the points A minus 1.1, B 2.3, and C 4.3, and draw triangle ABC. Color all points P inside triangle ABC blue, for which dpAB is equal to dpBC and PA is less than 3. The best and only strategy for such an exercise is to first plot everything. So we start with a coordinate plane and plot the points on the correct coordinates. Then we connect the 3 points to create a triangle. Then we take a look at the notation. dpAB is equal to dpBC means the angle bisector. And judging from the letter combination, both have the letter B, it has to be the angle bisector of B. So we measure the angle with a projector triangle and draw the bisector in the middle. Then we take a look at the other notation. PA is less than 3 means we have to draw a circle around A with the radius of 3. When we've done that, we can determine what we need to color. We need to color everything on top of the bisector, but only inside the circle and inside the triangle, which means that this line is the locus for this exercise. With the bisector in our pocket, we now have 4 locus-related lines. The circle, with the notation PA is equal to 3. Parallel lines, which we can recognize with dPL is equal to 3. The perpendicular bisector, which has the notation PA is equal to PB. And lastly, the angle bisector with dPL is equal to dPM. Of course, variations can occur by changing the numbers, the letters, or even the symbols. So, when working with the locus, be sure to memorize the notations, but know that they can change slightly. On to the next part of the paragraph, the incircle. Last episode I explained the circumcircle, a circle that goes on the outside of the triangle. Then it wouldn't be a surprise that the incircle is a circle on the inside of a triangle. And as this paragraph is called angle bisector and incircle, I think you can already guess what we need to do to draw that incircle. So first we need a random triangle. Of course, you can just also make a random circle inside, but the incircle is the biggest possible circle that is tangent to all 3 sides. Tangent means it just touches the side, but doesn't go through it. To find the midpoint of the incircle, you have to draw the angle bisector of at least 2 angles, but 3 is of course way better. If done correctly, all bisectors should intersect in one point. This is a point where you have to place the metal tip of your compasses. To find the correct place for the pencil point, you have to draw a line from the midpoint to one of the sides. Don't do it like this is wrong. make sure the line from the midpoint is perpendicular to one of the sides. That gives you the tangent circle we're looking for. When you found your point, place your compasses and draw the circle. If done correctly, the circle will just touch all three sides of the triangle. If it looks like this or this, then there are two possible problems. You either haven't drawn the bisectors perfectly and your midpoint is wrong, or your pencil point is wrong and you have to fix that. This is what the perfect incircle should look like. The incircle is much less forgiving than the circumcircle, meaning that even the smallest mistake will be visible here. So make sure to practice this a few times, as it will certainly go wrong the first few times. Also, as the incircle is on the inside, don't make your triangle too small, as drawing a smaller circle with your compasses is always tricky. And with that, we finish this episode. In the next episode, I will teach you how to calculate the circumference of a circle. Be sure to bring your calculator, you need it. I hope to see you then. Good luck!